All right, guys, this is episode 2 of the Mustang 2 install, where we've already done a little bit of prep work, but I kind of ran into an issue which I call decision paralysis, where you find all these different kind of good ways of doing this project and have a hard time deciding on which one. I finally got over that, which took me a couple weeks, and I'll show you all the design things I did on the computer here in just a few minutes. But we need to replace what we've cut out here recently. Me and Chris came out here the other night and cut out these pieces from the back to the front member. As you can see, well, this one's a little short right now because we cut a little section out there. In order to get this out, it was kind of a pain in the ass because it was welded along here and then on the back. So before a new piece goes in, we have to grind this down flat again. That happened on both sides. We also cut out the bar that goes across for the steering linkage. And before we did all of that, we took really good measurements, and you'll see on the computer drawing here in a second. A couple of the parameters that we needed to do. We need to make sure if we were gonna use bars again, which, spoiler alert, we are, we had to move the bars inward so that the link does not hit. And I'll actually pull something up so you can actually see it. All right, before these, the reason we're actually starting this whole process is when this bottom link was installed here, it was hitting right there at the bar that was holding the mounts, as you can see right there. So what we had to do is we had to make these bars go inward so that they're underneath the control arm bushing. We did that, and we also moved the tires in 1/2 inch on each side, or 1 inch total width, because his tires are really close to the fender well, and I wanted to give him a little bit of room, be able to turning radius and whatnot. So let's first go to the computer, and I'll show you the first design that I was thinking about doing, which is just flat plate welding. And then what we ultimately decided to do, go ahead and bend up some new bars and basically redo this the way they had it, because it was a really good idea, but just do it in a better way. One other thing too we had to do on this before I forget is we wanted to raise the mounting for the steering rack, because you had all those spacers underneath the steering arms, and I'll link back to some previous video for that so you can see all those spacers. So we raised this bar up 1 inch that connects both of the steering racks together. So let's go take a look at the computer, and then we'll start bending up some pipe. All right, let's go over the computer side of things so that you kind of have a good idea of kind of how I came up with what we're trying to do here. Hopefully this makes sense, and please comment down below if I overlooked something that I should have addressed. But let's look at the computer here, and forgive my dirty desk, I've got a lot of projects going on. All right, so here is Fusion 360. I use this a lot to kind of flush out some ideas about how I want some things done. The biggest issue here is you got to take pretty decent measurements to try to get all these, like this is the original frame rail shape, and it's got the correct angles and everything else on it. As far as this angle right here, as you can see, it's got the appropriate angle. And then I also took really good measurements for where these bottom bars are, or bottom bungs I should say, that would hold the lower control arm. So this was my original idea, was to try to use some flat plate, just cut it out with CNC. I would brace it from the back side with a bar from going from here to where it was originally mounted back here. And then the front, I was going to bend a bar from this all the way around to this and mount the rack that way with like a brace going up to this lower part of the frame rail. I decided against this. For one, it just doesn't look good. Structurally it would be fine, it'd be strong, but I would have to do something weird down here to get this bottom section connected. I didn't care for it. So I decided to go back to the bar style. All right, here is the BendTech software that I designed the new system or style. And in green here is the original, how they had the originals made. So they're just a piece of straight bar going across, connecting at the bottom of the frame rail and this back of this cross member. The red is what I redesigned it to be. And as you can see, the rack mount is 1 inch higher right here in order to give that rack a little bit of height so that I don't have to use as many spacers into the control arm, or not control arm, but the steering arm. And then I also moved in this bar right here to over here to gain me some clearance for that lower control arm issue that I was talking about. So the mount will be almost in line with the bar instead of offset to the bar, so the lower control arm can't hit, I guess is the best way of looking at it. So now that you kind of see the design, let's go ahead and do some bending. All right, one cool thing about the BendTech software is once you've bent up your design, it gives you everything you need to know. The first thing we're gonna need to do is bend those first bottom braces that basically set the tone for the rest of it. And what's cool is you get a printout just like this, and it'll tell you the length that you need to cut your pipe to and at what location you start your bending at. And we'll go through the whole bending process in just a minute. But on this particular piece, they wanted it to be 50 inches, 50 and 5/16. I get in the practice of I'll add an inch to both ends and then I'll cut them out at the end to get a tighter fit. If you're doing 2 bars or a bar in between, you may not want to do that. That's just the approach I take on my first couple bars to make sure the lengths are correct. So as you can see on this bar right here, my first bend location is 12 and 9/16, but because I added an inch on one side, it's actually 13 and 9/16. And if we go across here, I got 13 and 9/16 marked all the way around the tube. My next one is 20 and 7/8. And it's actually 21 and 7/8 because again, adding an inch, I got that marked all the way around. And the last one is 37 and 7/16. And I got 38 and 7/16, again, 1 more inch extra. So this bar will have 1 inch beginning and 1 inch at the end extra in case I need to shift the bar forward or backwards. I feel like more than likely the back is gonna be perfect and then all we gotta do is cut an inch off of it, but it's not a big deal. I would rather have a little extra than not enough. So let's go over to the bender and we'll go ahead and get this thing bent up. All right, the bender I'm gonna be using is the JD Model 2, JD Squared Model 2, I think it's what it's called. I've used this exclusively for 4 or 5 years. It's a really great bender. The only thing I can recommend if you do buy it is at least get the air over hydraulic. I got it from Swag Off-Road and it just mounts a cheap bottle jack from Harbor Freight. If you want to upgrade this one step further, you can get the electric hydraulic cylinder, but you don't want to be bending this stuff by hand. They have this little ratcheting mechanism you can use. I did for the first year before I bought this system, and it's not fun. And this has to be mounted really well if you're going to do that. The way you have to set these up is first you need to make sure your first bend is in there, which I haven't all my bends marked 1, 2, 3. So my first bend is number 1 right there. And I set it to the edge of the die. I don't know if you can see inside there, there's the edge of the die. So I bring it over there until that is just on the outside of it. The cool thing again about JD Squared, or not JD Squared, BendTech, is it actually gives you your angle that you desire and your spring angle. So it's telling me that if I want a 17 degrees, I need to bend the pipe 21 degrees. That is because when the pipe relaxes, it actually springs back. So you have to go over the bend that you actually need in order to get what you want. So my first bend needs to go to 20 degrees. The way I do that is I tighten up the hydraulics and I take the air line and I will pump it up until I get this down to 0. And I confirm that's at 0 by moving the pipe around to make sure it doesn't move. And since it doesn't move, it's clamped in, that means that's my 0 mark. And then I'll bring this all the way over to 20 degrees. All right, 20 degrees. You're gonna witness spring back right now. When I release the pressure off of this is actually gonna be pulled back on its own, and you're gonna see it move to, you know, roughly 17, 16 degrees there. So that's what the spring back is for. So I release the pressure off the hydraulics, take the slip off, I slide this to my next bend line, which is right there. And because this is kind of what they call an offset bend, it's just gonna go 90 degrees from the center line in order to bend it back the same amount it went forward. All right, got my die lined up with my mark inside there. I'm gonna put some pressure on this so it can't move easily. All right, so now it can't move very easy, right? I'll make sure my mark is correct, which it needs to come in just a touch.
Don't worry about it, you're still in good shape. All you gotta do is just tap it in. Just tap it in.
Mark is good. Now, the next really important thing is we gotta make sure that this plane is the same as this plane in order to get my correct spring back. The way I do that is I take a monkey wrench and I look down this edge to make sure that it's not planing up. And I can tell it's kind of planing up a little bit from the die in front. So I will jog it down just a touch. Right there looks very planar to this surface. If your angle was at 90, for instance, so the angle was further, you could take a digital level, such as this right here, and you'd put it on that 90, you'd put it on your die and make sure they're both the same. But because this angle isn't drastic enough to actually get a reading off of, this is something you're just gonna have to eyeball. So before I put any more pressure on it, I'm gonna look down at sights to make sure I still feel good about it, and I do. So now the next step is to bend this to 20 degrees so that it has an offset bend. All right, 20 degrees. When I release this, I'll do the spring back, as you can see. And now I have a perfectly nice jog. So the bar is offset in, just like we wanted to clear underneath the control arms. Tighten that down, take your slip off. We go to your next bend. Come on. All right, we get it lined up with the die just like the first two, and then we'll put a little pressure on it. All right, I got a little pressure on it. And just so you guys can see it referenced wise, I'm gonna grab the bar it's already bent so you can see what I'm talking about. Okay, here's the bar I've already pre-bent. As you can see, this is my offset jog right here. And then I have this piece bending up. This is where the rack gets mounted. And I measured the distance and I got it 1 inch up where the rack gets mounted to. So I gotta make sure when I bend this pipe that I bend it in the opposite direction. So this needs to face up. So that'll be important. So I usually keep the pipe that I need to reference or go the opposite direction handy so I can reference to make sure I've got this right. All right, so this is the jog from the driver's side. It jogs out and back in, and I want that pipe to be bent up in this fashion. In order to have that happen, I need to turn the pipe 100 or 90 degrees that direction, and it should bend up. So hopefully that makes sense. So we're gonna turn this to where this bend is 90 to that bend. And I need to shove this guy in there just a little bit. All right, right there at my die line. I'm gonna look down the scope here kind of and make sure this is perfectly 90. And again, if this was a drastic bend, you could take a level or a digital level and lay it against that side and then check if it's 90 against your die. But again, this isn't enough to be able to get there. So you're gonna have to just kind of eyeball 90 degrees. And that right there looks pretty good. I'll just bump it just a little bit. Yeah, it looks really good to me. I'm actually gonna come over to this other side and look down it too, just to be sure. And it looks like 90 degrees to me. I'm gonna confirm it's the opposite way of this one, so I don't screw up anything. And if I look at, if the pipe is laying side by side, you can see how this one bends that direction. When I bend this one, it's gonna go the opposite direction. So I'm exactly what I need to do. All right, we can lay these side by side and see if we did it right. And if you're looking at it, looks pretty damn good to me. This is where you're gonna have to maybe tweak these up a little bit to get this particular angle perfect. It looks like the first pipe that I bent, looks like it may be a little bit shallow. It looks right on. But as you can see, my bend lines line up, and these are just maybe like a 16th off, which isn't a big deal. Again, I always leave a little extra on each side, and it should be good to go. Let's go over and show you exactly where these fall, and then we'll get the cross brace cut up and cut out. All right, as you can see, this is where the pipe's gonna fit, and you can see that these bushings are now on the other side of the bar, which is what we were looking for. It's going to make sure that we have full travel like we're supposed to. And this is gonna be a little bit tricky. We're gonna have to actually do it on the welding table to make sure that this is clocked correctly when we weld this brace in, to make sure both of them are angled this way appropriately. So hopefully that makes sense. All right, what's cool about the BendTech software is not only it gives you all your bends and whatnot, which is nice, but it also gives you all your straight pieces with your notches cut out. So our next thing to do is we need to cut the bar that goes between the two racks, or that holds the rack, I should say. And it says I need to cut this piece 20 and a half inches long. So we're gonna put it on the saw right here. We're gonna move it over to 20 and a half inches after we measure that. 21 and a half. 21 and a half right here. Always make sure that you draw a arrow and don't draw a line. If you draw a line and it's at an angle, you don't know which side you actually made the mark on. So always draw an arrow to exactly where you want it, and then you put your blade right on the arrow. Another tip for you guys is when you're cutting this, make sure that the back of the tube is touching the bottom of this platen, and the front of it's touching the bottom of the platen, so that when it cuts through it, it cuts through it at a 90. If it's not like that, you may need to adjust your sawhorse holding it on the other end. I've made that mistake a few times and it's bit me in the ass, so that's the only reason I'm telling you. So slide this guy down here. I'm gonna check to make sure I'm touching there, That's good. And then I'll put the saw blade right on my arrow, and then I'll make sure and confirm that this is where I want to be. I'll take my measuring tape, put it up against the saw blade, and I'll look down here and it says 21 and a half, exactly what I'm looking for. I'll tighten this guy down and turn it on the saw. All right, if you're gonna use these tube wraps, I highly suggest you get a cut-off thing. This is like an Amazon special, just so you have nice straight cuts. One also thing you need to do is you need to make sure you leave just a little bit extra on one side that you do your wrap on, and I'll show you why here in just a second. Let me get a pair of scissors and I'll cut this line out, and then we'll show you what it does on the tube. How these tube ends work is you'll put it around the tube, just like that, and you'll line these two lines up going in the center. And if you can see on this one right here, see that line going all the way through? If you line those two up, then you have it perfectly squared to the tube. The reason I leave that little extra edge on the top is so that I can lay it over and have a place to tape. So try to get that nice and snug. Lay that across, and now you can slide this up and down the tube and rotate it. So you drag this guy over to the end of the pipe, like so, just like that. And then you take this one, obviously the cut's gonna be on this side, so you need to do the same, wrapping it around the pipe and taping it as you did the first one. Okay, now that you got your tube ends on here, I'll tell you what the measurements actually mean. So the first measurement is, well, the first one I'm gonna look at is the second measurement. And it says 19 and 11/16 from the other end of the tube. So we lay this down and take our tape measure and go from this end of the tube over. We're gonna line this one up to 19 and 11/16, which is just a little bit there. I believe it's gonna be like that. 11/16, perfect. And then the other one's the exact same, so we go over here and take a measurement, and we'll pull this back to 11/16, which is something real close to that. The second number on here says 17 and 7/8. So between this one and this one, it should be 17 and 7/8. That's how you confirm you're correct on the tube. And we need to come in just a little bit, it looks like. So we'll slide that down just a little bit. Slide this down just a little bit. We'll remeasure, make sure we're at 17 and 7/8. As you can see, we're right on the money. If these marks are correct, which it looks like they are, you can then take your magic marker and you go around this guy just like this. All the way around. Okay, and that gives you your cut. Do the other side the same way. This gives you the ability to use a cutoff wheel instead of a notcher like I'm about to show you in just a minute. So as you can see, these tubes have marks on where they're going to be notched, and what you could do is just take a die grinder and cut as much as you can out, then take a grinder like a flap disc and then make sure you have this line cut just perfect. And if it's perfect and you've done everything else right to this point, this will just slip right in exactly where it needs to be. But because I'm lazy and I have it, I'm going to show you the tubing notcher and how it operates real quick. All right, this is actually a JD squared, I think it's called a Beast tubing notcher. It's extremely versatile. It's not as fast as some of the other kits out there, but what I like about this is you could take a bent piece of pipe and lay it on this board and be able to do a cut in where you need it and not have where you have to be in line with something. So I do like that, but it is kind of a bear sometimes to set up. This is pretty straightforward. The idea, what we're gonna do is now we have our marks on our tube, we can lay this in here and get this over to our cutting edge, which is something like that. And we're gonna slide this over until, if you're looking on this side, probably easier. You see that line right there and see the hole saw? What I like to do is make sure that I am even straight and to the side, and I'll show you how I confirm on the second cut that we are completely 90. So you tighten this thing down so it can't move, and now you have a hole sawed cope, as you can see. And it looks like it came a little bit tight on that line, which isn't a huge deal. You just want to make sure that on both sides, which they're both about perfect. If you see on the top, it's got more of a cope than it really needs, so I could take it on the belt sander and grind that off. But I'll show you, I actually end up taking this and then chamfering the edge so I can get a good penetrating weld. So for the next piece, when we flip this around, because this is adjustable height as well, there's a lot of adjustment there. What I always do is I rotate it all the way around in the same plane so that if this is off by just a little bit, that both of these sides will be on the same plane when you go to weld everything up. So what I do is I rotate it to make sure that this bottom is over here on this bottom. I get it lined up to about where I want it, where it's touching. It looks good there. And then I take and just kind of snug it. Then what I'll do is I'll take my digital protractor or digital level. And I can see that I'm actually 1.9 degrees. That's just the reference line. That's we'll say 2 degrees. That's what this is in line with, right? So if I take another pipe and I put it inside here and I put this level on there, when I rotate this and I get 2 degrees, then I know that this is gonna be in plane. 1.92 degrees right there. So now we're in plane with these 2 items, right? I come over here and confirm that my cutoff mark is gonna be at the edge of that, and it is, and then I tighten this guy down. All right, so now that everything's confirmed to be in parallel and in plane, I can go ahead and make this cut. It certainly does. After I get everything measured and in parallel with each other. We'll go just like that. All right, so that's gonna be the next step, is getting this jigged up on the table to confirm that all our measurements are correct. Well, would you look at that? We have all our parts on the table. Nothing's been welded yet. This is just kind of the jig that I kind of made up to get all the parts aligned and square and how I like them. This is much easier to do on a table than it is to put a single bar in a car. If I was gonna do a single bar in a car, I would have to jig the entire car up. So this kind of eliminates some of that. Let me explain a little bit what's going on. Is this back bar right here, this 2x4, it is actually representing the cross member, and then these small 1x1s are representing the frame rail. Let me take you out to the car, I'll show you that real quick. So this is that back cross member I was telling you about. That's what's mimicking it. So this is where they will be welded to. And then the frame rails are on each side. And again, if on the table, if I'm square, flat, and level, and I've already measured this and it is square to the rear axle, then everything should be square when I put it up here. All I have to do is level it forward to rear, which I've leveled the frame rail, and then I just have to make sure everything's square. So it should be a pretty simple process of getting that lower control arm made. I'd rather do it on the bench and get it done right and square and flat than try to put 1 bar at a time up here and then have to struggle with trying to get everything pushed around. This is just a far easier way of doing it. All right, so now that you kind of see what we're doing, the biggest thing for us now is I've got to measure from the cross member to the first tab, which I made these tabs. I did not mention that. I don't think I have any video of it. If you're interested in seeing how I make these, it's a CNC plasma machine. I know most of you guys don't have much access to them, but it may be interesting. So let me know down in the comments if that's something you're interested in seeing. I'll do a video on it. I've got 4 of them made. I still have to make a crossbar between here and here, which I've got pipe over here for. And once we get everything welded up, we'll install that pipe so that it kind of stiffens this area. The big thing is making sure that these distances are correct, and including to the edge or the center of this ball joint, so that we know that we're square inside the car. All right, so that's gonna be it for this episode. The next episode, everything's gonna get welded up. I'll probably put a time lapse for that. And then we're gonna get it put in the car. There's still some cleanup to do on the frame rails, as you saw in the video, which isn't a big deal. Just gotta get out there and do it. And then this will go in. After that, we can start making our top brackets that's gonna hold our upper control arms. So if you guys enjoyed the video so far, make sure that you put a like down there. It helps us go up the logarithm. And if you're not subscribed and you wanna continue to follow along, make sure you're subscribed, because this will probably take about maybe 3 or 4 more episodes to kind of complete. But we are cooking with gas now. This is the biggest time-consuming part, is coming up with the design and getting it jigged up so that everything is square and correct. The next section, there won't be as much of that, other than, we still have to figure out how we're gonna hold the upper arms, which I've already kind of got a design for, and I will make sure I will put that in the description, or put that in the video, sorry, so that you can kind of see my thought process there. Okay, well, we appreciate you watching, and we will see you next episode.